Boom. All right, the amplitude for the first one, what is it? Very good. Remember that tangent functions do not have an amplitude. They go to infinity and negative infinity forever, right? Okay, what is the equation of the midline? Very good. Any questions on how to find that, or y'all remember how to find that? So there are two of these on your quiz where I give you like two different types of functions and ask you to find these things, okay? All right, amplitude, equation of midline, phase shift, and period. Let's do those at the same time, period and phase shift. So the period, if there's a 1/2 right here, what are we doing horizontally to our graph? Stretching it by 2. So what is the parent period for tangent? Pi, and then you should have multiplied by 2. So this period does end up being 2 pi. Just don't multiply it by 2 pi, please. It's not 4 pi for this one. Remember, tangent's period is pi. And then for the phase shift, did you guys factor out the 1/2? So just remember, when you divide, let me get a different color for y'all. When you divide pi over 4 by 1/2, you got to multiply by the reciprocal. So it's like multiplying by 2. So this will end up going where? Pi over 2 to the what? Very good. Right pi over 2. Make sure on your quiz you can put a capital R or a capital L, and then you can just put pi over 2. That's fine with me. So you just divide by the number. Yes, you factor out the number in the front. And remember, whenever you factor out something, you're dividing it out. Yep. Very good question. All right, so I'm going to come down here for the asymptotes just because I ran out of room. But then I'll erase it so we can do the next part. So the asymptotes for number 1. Where are my asymptotes supposed to be for a tangent function? Very good. Pi over 2 and 3 pi over 2, right? And they should both say x equals. I'll do that in a minute. So to each of these asymptotes, because they are in the period, I'm stretching them by 2, and then I'm moving them right pi over 2. So did everybody multiply each of these by 2? Okay, so that'll give me just pi and 3 pi, right? And then did you guys add pi over 2 to move it to the right? So what's pi plus pi over 2? Good, 3 pi over 2, pi and a half, which would be 3 pi over 2. Let me move my Zoom people. Does anybody need me to show them how to get a common denominator? It's okay if you do. Okay, I just don't want you to miss it on the quiz because you don't know how to add fractions. If you get a common denominator, the common denominator would be 2. Sorry, I forgot that y'all get cut off down there. Is that better? Common denominator would be 2. So if you multiply the bottom by 2, you also multiply the numerator by 2. So 2 pi plus pi is 3 pi over 2. Okay? So the first one should be x equals 3 pi over 2. And then the second one, if I take 3 pi and add pi over 2, let's do the same thing. Get a common denominator, so put it over 2 as well. And then you have to multiply the top by 2 also. So what's 3 times 2? 6. So 6 pi plus 1 pi is? So the other asymptote would be 7 pi over 2. Does that help? It does. Okay. You can't see it. Because of my Zoom people. I'm going to minimize y'all completely. No offense. I always want to do everything to the left. I always want to subtract. If it says right, make sure you just add. Yeah, I don't know. Even when it says right, yeah. Factor. Put it in factored form. Do that very first if you have to. Are y'all good with number 1 though? Can I erase this? Yeah. You got it, Chris? No. Write it. Right, so remember, if it's tangent, secant, cosecant, or cotangent, there is no amplitude. They go up and down forever. Now, your quiz does have a lot of sines and cosines because that is typically what's on the exam. There's usually a question on the exam where it'll give you an equation like this and say, what are the asymptotes? And I will show y'all one more time the shortcut way to do this. But the majority of the other ones are sines and cosines. And we'll talk about why today. We've already said it once, but we'll talk about it again today in today's notes. Online people, am I good to do number 2?
Yeah.
Yes.
Okay, awesome. All right, so for number 2, what is the amplitude? None? Remember, secant goes up and down forever because we take the cosine graph and we flip the pieces. What is the equation of the midline for this one? Good, y equals 0. If there's no shift up or down vertically, then the midline will still be at 0. All right, so let's do the period and the phase shift. For the period, look at that 2. Horizontally, if there is a 2 in front of that x or that angle, what am I doing to my graph? Compressing it by a half. So this is where it gets tricky because y'all don't pay attention to the function. Make sure you look at which one we're dealing with. What is the period of secant? 2 pi times a half is just pi. We okay there? Okay, good. Yay. All right, so for your phase shift, you got to factor it. So divide this 2. And we can't do pi over 2 divided by 2 because that's 2 division bars. So remember, you're going to do pi over 2 times, what's the reciprocal of 2? 1/2. So my phase shift is going to end up going pi over 4 to the good. So you can say left pi over 4. I'm fine if you just do capital L on your quiz. Y'all okay with the phase shifts and all that? Awesome. All right, so brain fart. Oh, I just remembered we're doing asymptotes. All right, asymptotes for secant. A lot of you flipped back. That's okay. You will get to use your notes on the quiz and the test. That's fine. But if you're trying to remember them so you don't have to look back, because that does take time on your quiz and test, remember, secant will have asymptotes where the cosine is 0. Because if you flip 0, it'll be undefined. So think about your unit circle. Cosine is the x's. Where are my x's 0? Good, pi over 2 and 3 pi over 2. So these actually ended up being the same. Now what am I doing to each of those? Times a half. Times a half, because we're compressing them in by a half. You got to do that first. It comes first in your parentheses. No, no, no. I did not teach you that. You don't multiply by the period. Look at the number in front. That helps you find the period, but that is what we're doing to the whole thing. So we're pressing those asymptotes in by a half, so you should have multiplied each of these by a half. So does everybody agree that's pi over 4 and 3 pi over 4? Yeah. Okay, and then what am I doing with those? Subtracting pi over 4 because we're moving it left pi over 4. So minus pi over 4 minus pi over 4. So what are my 2 asymptotes? Good job. Are you proud of yourself? Good. You need to know how to do this for your quiz. People at home, are y'all okay with this?
Wait, what did the second one say?
The second one says pi over 2. 3 pi over 4 times pi over, or minus pi over 4, excuse me, which would be 2 pi over 4, which reduces to pi over 2. Okay? That's okay. It's kind of small and kind of blurry because my markers are fat. I need to buy a skinny pair this weekend. Problems at y'all already, where you've put the equation in Desmos or you've looked at the graph. So that's what we're going to be doing, just with a real world problem. Y'all have that. I'm going to go ahead and flip. And I'm gonna kind of format it like we did yesterday because that worked well for most of you. So page 31. Trig regression and applications. Getting to the back of my notebook so it doesn't want to lay flat. All right, we're going to start off just like we did yesterday with a question. I need everybody answering. My online people, that means you too. Don't answer right away. I want you to think about it first. And then if you want to answer, let me see a hand or something. All right? And if you've been on Zooms all week or you've been in class all week, you may already know the answer to this. Good. Hang on. Let them think first though. Do you have a reason for it? You don't say it. Just don't say it. But you have a reason. Beautiful. You don't have to write this down. Y'all like to write everything. If you want to write it, that's fine. You don't have to though. I will tell you when to write. And why? All right, so I already have somebody wanting to answer. Online people, is that okay with y'all? I'll repeat what they say. Okay, all right, let's go, Birdie. What you got? Cosine and sine. Can you tell me why? Okay, good. So cosine and sine are continuous waves, right? So what he said was there's no asymptotes, meaning they won't go to infinity and negative infinity. Do things in the real world go to infinity and negative infinity? Not typically. So I do agree with you, cosine and sine. I don't want to say it like that because they're about equal. Cosine and cosine you will use in the real world about equally, okay? So when we do these application problems, there are no application problems for tangent. There are no application problems for cosecant. They are all sine and cosine. When you get your application worksheet, all 5 problems, sine and cosine. All right? Do you guys remember from Tuesday what kind of real world things we could use to model with a sine or cosine graph? So things that would repeat and cycle back. The stock market will go up and then down and then up and then down, right? What sales? Good, jacket sales. Anything to do with weather. Because we know that in North Carolina, once it hits April, our temperatures go up. And then when it hits about October, they go down. And then they'll go back up once it hits like March or April again and down, right? So anything that will cycle back and is periodic will repeat. That's what periodic means. These are my favorite types of problems. You're going to see one in a minute. A Ferris wheel. It does go around in circles. So does a tire, right? So if we're talking about KJ gets on a Ferris wheel and rides it for 5 minutes, write a function that could model his distance from the ground. When he gets on the Ferris wheel, he's not on the ground. How many of y'all have sat in the seat when it's on the ground? Yeah, your butt would be on the ground. How the heck is it supposed to take off without chopping your legs off? That's my favorite thing, because last year them kids were like, it should start at 0. And I was like, no, you get on the little platform and then you like have to kind of jump up in the seat, right? Yes, unless you're big like me, then I don't have to jump. But he'll start like here. The Ferris wheel will go up. And then it'll come back down. And then it'll go up. And then it'll come back down, right? So that would be a sine or cosine function. Y'all get the gist, right? Sine and cosine. Everybody's okay with that? Okay. Which one do you think we use for regression? Why sine? Okay, it's odd. That's what I'm hearing. I'm not saying that's right. It's odd.
Sine is using the y-axis.
They both start on the y-axis. Cosine starts at 1, goes down and up. Sine starts at 0, goes up, down, and up again. No, just which one are y'all trying to tell me it is? Okay, why? Why do we think it's sine? You were on to something. Sine function starts where? At 0. Regression equations tend to start at the origin because they are trying to approximate what kind of function would go through the points, right? So anytime we are doing regression, it can be modeled with a sine function. Does everybody understand that? If I give you a table of data and I say write a trig function that can model this data, we use sine because it starts at 0, 0. Now, I did show you on Wednesday, I blew your minds, probably I didn't like it, but I did show you on Wednesday that any sine or cosine function can be written with sine or cosine. Because I showed you when we draw out the waves completely, you could just start in different parts, right? So that's why we're able to just use sine. Do I need to show you that again, or y'all understand what I'm saying? Okay, what is regression? That's where we're going to start. What's regression? We have done it before. So I'm hoping someone will come up with an answer. You also do it in Math 1 and Math 2. Man, I wish my Math 1 kids were in here. They would answer this. They'd get it right too. Surprisingly, they'd get it. No, regress in the real world means to go down. What is regression in math though?
Oh, wait, no.
If you go back and look in your notebooks, there is in Unit 2 a page that says exponential regression. Look in your table of contents. It'll tell you what page to flip to. That's the whole reason why we do it. Kevin, I'm so sad. And Cody. And Javion. Y'all know what regression is? Jack, Daniel, Tara, and Kelly. I'm real sad with y'all. A function of best fit. Y'all remember doing line of best fit? You remember when we did exponentials and logarithms in here and we did the exponential of best fit or the log of best fit? Okay, write it down again. Maybe it'll stick this time. With y'all, it takes 2 or 3 times for it to stick. Finding a function to best fit a set of data. Kel, I'm gonna pick on you. Miss Kane is so sad.
Love Miss Kane.
Finding a function to best fit a set of data. She taught you regression.
I remember.
Y'all were in Unit 2 too, and y'all all, like most of you got it right on the test, but Lord, y'all can't remember what it is.
But that was like years ago.
What? When I taught it to you, that was Unit 2. That was like a month and a half ago.
Oh, I thought you taught Miss Kane taught me.
Nah. So trig regression. We just said we're going to use a sine function. Ooh, spelling is hard. We use a sine function for trig regression because it starts typically at 0, 0. I know that's not the best. I'm not a great artist. If this was our graph, if I graphed the data and this is the points it gave me, most of you would want to use a sine function anyways because it starts at 0, 0. But would you have to use a sine function? You could use cosine. You could choose this point right here to this point right here. This blue part is even, right? It doesn't matter which one it looks like it should be. The waves are continuous. So as long as it is continuous with the waves and it's periodic, which means it goes up and down, then it doesn't matter which one you use. So even if you're in your head, you're like, okay, I feel like this should be cosine. Doesn't matter, because even if it looks like cosine, I'm gonna do it down here. Even if it looks, dang, that was ugly. Even if it looked like cosine, you could pick part of it and write a sine function for this part. Does everybody understand that? That's the part my kids have the hardest time with. They're like, why are we using sine for all of them? Because when you're doing regression, you need somewhere to like start the regression at. In the real world, things typically start at 0, or they start at some kind of origin, and then they're gonna keep going. Does that make sense? So we're gonna use sine. I do want you to write this down. As long as the data appears to be periodic, I told you these are the only like notes. We're about to write down steps and we'll be done with notes and I'll just do examples. As long as the data appears to be periodic, which means it does what? Repeats. Good. Yep. Very good, Chris. It cycles through, it'll repeat. Then we can use a sine function. So trig regression, another name for it, you don't have to write this down, you don't have to know this. I'm just giving you like an example. In college, they don't even call it trig regression, they call it sinusoidal regression. It's sine regression. They use sine for everything because it starts at 0, 0. Okay? All right, so let's see if we at least remember how to do these. Hoping y'all will at least remember how to do them since y'all couldn't tell me what regression was. So sad. All right, what are my steps? Where can we go put the table of data?
Desmos.
Thank you, Kevin. Why are y'all saying 0, 0? 1. Go to Desmos. Y'all threw me off by saying 0, 0. I forgot to put my number 1. Okay. Once you're in Desmos, Kevin, what did we click to put the table in? Do you remember?
Isn't it like the plus sign?
Yep, it's a plus button. You're going to hit the plus button. It's in the top left corner to add a table and enter in your data. They will give you the data. And then there's only one more step. When we did exponential regression, I don't want you to write this. I'm not writing it either. Remember, we did y1 squiggle a times b raised to the x1. Y'all remember doing that? And with logs, it was log, I think we did log base b of x1. y1 squiggle log base b of x1, right? So the third step, you put in the standard form of a sine equation. So we are going to put in y1 squiggle. What goes out front? of a sine function? What's out front? The amplitude, very good. A sine what's in front of the x? Good, it is a b. It's because it's the factor that you multiply the period by to find the period, right? So this is bx. Then we have our phase shift. And then what's on the outside? Plus, isn't the back number the midline? Okay, y'all are staring at me like you don't know what I'm doing. You don't know what letter they use, but I mean, they used A, B, and C, so what do you think they used for the back one? D. Boom. What did I forget?
Isn't the C supposed to be negative? Or like, isn't it supposed to be minus C?
It actually does not matter. You can put minus or plus because that just means they're going to start it on the left or the right. Doesn't matter because these waves are continuous. But what did I forget? Good. Where, Oswald? Good. Remember, it's y1 and x1 because in Desmos you can put in more than one table. So if you have two tables in there at a time and you want the second table, it would be y2 squiggle a sine b x2 plus c plus d. Okay? I feel like we need to see an example of this, yes? So I think just doing 2 examples, we would be fine. People at home, or if y'all are okay with that, I'd rather do 2 instead of 3. So y'all have more time on your homework. All right, I am going to do, see, that says what is the period? Interpret the amplitude. Yeah, let's do number 2 on the worksheet. So you guys, your worksheet was in the top left corner. It was the top one. The other 2 are for next week. People at home, I put this on Canvas for y'all. You don't have to print it though. You can just use it to reference, okay? And you can write the answers in your notebook. All right, so it says the table shows the average sales in millions of dollars of an outerwear manufacturer for each month T, where T equals 1 represents January. It makes sense that they would sell a lot of outerwear in January and February, doesn't it? Why? Because it's cold. Then we start getting to May, June, July. There ain't that much because it's hot. Then we start hitting October, November, December, and it starts going up again because it starts to get cold, right? So every year, does everybody agree this data is going to cycle back through? It's going to go up and down, up and down, up and down. It looks periodic, which means we should be able to write a what equation? Sine. So if you read, we're not doing a scatter plot. Y'all don't need to do that. If you read part B, find a trig model that fits the data. We're going to use a sine function. So where can I go to put this table in? Desmos. You guys can go to desmos.com on your phone and do it with me so that you practice. People at home, I'm going to do it on the website Desmos, but you guys can totally do it on your phone as well while you're watching. If you have, there's also a Desmos app that is even easier to use than the website if y'all wanted to use it. Yeah, so you don't have to do it, Chris, if you just want to watch. That's totally up to y'all. I'm not going to make you do it. I'm going to add a table, and my months go from 1 to 12. So I'm going to put all those in. Let me minimize y'all. Uh-huh. Says T, but yes. And then the sales 13.46, 14.15, 8, 4.85, 2.54. Sorry that I'm talking out loud. I'll mess it up if I don't. My freshmen have learned that, and they're so sweet. They call it out for me. Yeah, well, not my in-person ones. They don't get to be lazy, because if they don't do their work, I make them call their parent in front of me. Yeah, I should do that for some of you.
Please don't.
And then when you have your data in, if you'll just kind of look up at me, so I know I'm good to keep going. Fast typers.
Bro.
You'll like this stuff, it's easy. There's usually one regression problem on the exam. A couple years ago, it was a sine one. And then I think last year's was exponential. And some of my kids missed it. And I was like, are y'all freaking kidding me? I was so mad. I think most of us are done. If you're finishing, everybody just look at this really quick. Y'all can't see it. I hate how my projector cuts everything off. What the heck? Hang on, I'm gonna get it where you can see it. Okay, y'all see this little magnifying glass right here?
Yeah.
That's your zoom fit button. So if you hit that, it fits those points really nicely on the graph. Although I can't get to mine now. No. Let me get to the zoom fit button, you piece of crap. All right, there we go, boom. So do you see how they go down and back up, and then they'll go down and back up, blah, blah, blah. Everybody's okay with that? All right, so then you click underneath it in a new box, Y1 squiggle. Why do we use the squiggle?
Because it's not exact.
You're my favorite. Cody, you're my favorite too. It's not exact. You are approximating the sine function that will go through these points. Remember us talking about that in unit 2? All right, Y1 squiggle. Good job, Cody. Good job, Oswald. A sine parentheses. What do I type next? Look in your notes. BX1. It's right here, babe. But also it's in your notes. A sine BX1. Thank you. Thank you, KJ. Plus C, and what goes on the outside? Plus D. Do you see how it tried to fit a really nice sine function? Yeah. People at home, y'all can see my graph okay, right?
Yes.
Okay. So what I'm going to do is I'm going to write this equation down while I have Desmos up, because I feel like we're probably going to need it. Is that okay with y'all? And that way I can flip back to my worksheet. All right, find a trigonometric model. So this would be y equals, are y'all good with 2 decimal places? Y'all know I'm usually good with 2. So y equals 6.42 would be the amplitude. Right, because that's the A. Try to move it. Chris, I can't move it up so you can see, babe. You're gonna have to look on your Desmos, okay? 6.42 sine, my B value, I'm getting 0.56. Is that what y'all got? Okay, 0.56 x plus 1.30. And then plus 7.87. Yes, I put 1.30 because I'm rounding to 2 decimal places, but yes, they are the same thing. Yep. Okay, so this is the equation we got. Y'all okay with that? All right, this is my favorite. What is the period of the model? Yes, Ross, good. What's the period of a sine function supposed to be?
2 pi.
2 pi. He said this is 0.56. So we multiply by the reciprocal, because remember, if it's inside with x, it does the opposite, right? So I'm going to type that into a calculator. Y'all could type it into Desmos in a new box. But I'm going to do 2 pi times 1 divided by 0.56. And I'm getting for the period that it will repeat every 11.22 months. 1 over 0.56. Do the reciprocal. I'm not trying to roast you, so don't get your feelings hurt. Do you have glasses?
No,
You need to get them.
I have 4 white.
Okay. All right. Does this make sense? Is it reasonable in the context? Who thinks they can explain that to me for extra credit? Do you think it's reasonable that this will repeat after 11.22 months? Raise your hand if you want to try to get extra credit. Online people, you can just unmute and talk to me. They don't got no hands raised. Hands raised, raise your hand. But then go, yes. Y'all can both go. He's so sweet. Go ahead.
Well, it's every 12 months. A year is 12 months.
A year is 12 months. Keep going.
So, if it's 11.22, and this is a graph of 12 months, then how, I don't know what I'm saying now. I lost
Don't think about the graph as just 12 months. Remember, this is going to repeat and keep going and keep going and keep going. So what this is saying is it will complete one full cycle where the temperature goes up, down, and back up in 11.22 months. Does that make sense? Why?
because
January is like
I think I know what you're trying to say. Keep going.
13.46 is like January, and that's what that means.
You're thinking into it way too much. I'm going to say it one more time. I'm trying to make it easy for y'all without giving you the answer. The temperature, if you look at the table, goes up. Then it goes down. Then it comes back up. Good, KJ. Look at your table. January is the same as November. How many months apart are January and November? 11. So what this is saying is the jacket sales or the outerwear sales will go up, down, and back up every about 11 months. That makes sense because 11 months is close to a year. It should take about a year for it to cycle through, right? That's what you would write down. Do you think it is reasonable? Yes, because it's close to 12 months. Or yes, because January is the same as November. Or yes, your explanations could vary. Are we okay with that? As long as you say something like that, that makes sense and talks about the period repeating after 11 months, I'm good. You say something crazy like, yes, because January and July are the same, I'm gonna be like, what the freak are you looking at? Okay? All right, the next one. Interpret the meaning of the amplitude. What is our amplitude? Very good. 6.42, which we know because we've been doing a lot of this, right? 6.42 is the amplitude. What does the amplitude go up and down from? Not 0. Good. The midline. Look at your midline, everybody. 7.87. That means that is the middle number of sales, or the, what do we call something that's in the middle? The real word for it in the real world. The average, KJ's feeling it. Good job. The average number of sales is 7.87 millions of dollars, right? So the amplitude is 6.42. That means it's going to go up 6.42 from that middle and down 6.42 from that middle, right? So what's something else they could ask you based off of these two things? Good, 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 good. Extra credit. The maximum number of sales and the minimum. Could you find all those things? Just from looking at the equation, right? We don't really need to do anything with the graph. I need y'all to be able to find the equation, write it down, and analyze the different features. I don't need to write these, do I? You would add these to get the max, and then you would do 7.87 minus 6.42 to get the min. All right, let me do some mental math. So this would be 14.29, and this would be 1.45. Did I do that right? So it doesn't match the table exactly. That's a really good question. So remember, when you find this equation, you are approximating what will touch the most points. So if I look at my graph again, some of these points aren't on the graph exactly. So the max from the graph is 14.29, which is what I just got when I did the adding of the midline and the amplitude. The only red dot that looks close to that, and it did actually, nope, that's not it. What's this point? 14.177. So it's not exact. It wants you to go off of the equation because it says interpret the meaning of the model's amplitude. Does that make sense? So if it says use the model, you're using your equation, not the table they gave you. Y'all think you could do one of these on the quiz? Okay, good. So can I show you the second type of problem we'll be dealing with today? And by we, I mean you on your homework. I am going to shorten that for you, I think, though, because y'all have done pretty good today. People at home, y'all are okay?
Yes.
All right, so let's do another example. Y'all can put this in your notes. Let me share to my desktop because I've got it pulled up here. Holy crap, so much going on this computer of mine. All right, here's our next example. You don't need to write it. I can put a picture of it on Canvas, okay? I just want us to talk about doing it together. Sound good? All right, so a Ferris wheel is 4 feet off the ground. Does everybody agree this is going to be a real world application? A Ferris wheel goes up and down and around forever and ever until they stop it, right? Okay. I'm going to draw a picture. That is my advice to you. Anytime you get a word problem, you need to sketch something because otherwise you really don't know where to start. So we know we got a little Ferris wheel. Your Ferris wheel should be off the ground a little bit. Gosh, my drawing is terrible, but it's okay. I'm gonna draw me on the Ferris wheel. Here I am. Looks like I'm holding on for dear life, like in King Kong. Anyways, a Ferris wheel, Ross like that. How high off the ground is it? Okay, so we know this bottom point is at 4 feet. Does everybody agree with that? Okay. All right, then it says the wheel itself has a diameter of 24. So who can tell me what that means? All the way around the wheel is 24. Which part do we need? Do we need the horizontal or do we need the vertical? The vertical. So from here to here is 24, right? Sorry, I got the hiccups, y'all. Okay. So the maximum is 28. Very good. And what would the middle be? If this is 24, what's half of that? So this piece would be 12. So Ross, what's 14 plus 12? Good. Your midline would be 16. Do y'all see how we did that by sketching it? Do you know how hard it would be to try to do that in your head? No, like last year, them kids they spent 20 minutes on this problem. I was like, did any of y'all try to draw it out? And only one person had. I was like, Lord Jesus. Did I lose anybody or y'all are okay? Okay, you know the diameter is 24. So that means the radius would be 12. So this is going to go up 12, but it starts at, so 4 plus 12 is, very good. You're good. All right, so let's go ahead and start to try to write this equation because it says write a cosine equation. We know it's going to be y equals. We know it's going to be cosine, right? The 4 is not at the front. What goes at the front? The amplitude. So how many does it go up and down from 16? How many does it go up and down from 16? 12. Take the maximum, subtract 16, that's 12. Take 16, subtract 4, that's also 12. Does everybody agree the amplitude would be 12? Okay. All right, then we know what? What else do we know? Just from what we've drawn so far. The midline is what? Plus 16 on the end, good. So this is where it gets to be a little tricky, okay? So y'all hang with me. It was shifted and there is a period change. Of a cosine function, the period is typically 2 pi, right? When does it say the Ferris wheel repeats? Every 60 seconds. So what do we multiply 2 pi by to get 60? That would give you 60 pi, so you're close. 30 over, there we go. Then the pi's would cancel, right? So if I want to multiply this by 30 over pi, what goes in the parentheses? Look at y'all. I know it's hard. This is one of the hardest ones you could see. I'm doing the hardest one in the notes. On your worksheet, and don't pack up, I've got 4 minutes, we're good. But on your worksheet, a lot of these already give you the equation, and you just go stick it in Desmos, okay? I'm giving you a challenging one. Right, we're trying to make the period 60. So how do I do that? By multiplying by 30 over pi, which means the inside should say the reciprocal, okay? And then there's one more thing we do have to add to this one. This part is the hardest part for y'all to really get or understand. I'm going to be 100% real with you. It was hard for me to get or understand too. Ben is sitting in a chair that is 10 feet above the ground already. You have to think about how a Ferris wheel is. Everybody just listen. If I have a big old Ferris wheel, I'm going to try to draw it the best I can. And this is 4 feet right here. If he's getting on 10 feet off the ground, Ferris wheels go clockwise. So he's going to be over here and he's going to be at like 10 feet. This is where he's getting on. So it is shifted to the left. Ferris wheels go clockwise. It does make a difference. You got to put plus 10. But he's starting 10 feet above the ground. Now, a lot of you are saying, okay, but that X distance isn't 10 feet. Correct. It's 10 times pi over 30. Okay? This one is the hardest problem you could have. This is the equation you would write though, and then to find when will Ben be 20 feet high, where could you go put this equation? In Desmos. There are none of these on your quiz. There is a regression one. There are none like this. On your homework, I would like for everybody to try 1 through 3. The homework is on the back if you didn't know. Flip your sign sheet 1 through 3. And then number 5 is up there if you want practice before your quiz. So if you do number 5, I'll give